Good afternoon, ladies and gentlemen. My name is Rambi from Glasgow, Caledonia University, and I'm pleased to stand here and give you a presentation for my research. And the title of my presentation is a survey of failures in a Chinese wind farm. Okay, let's give you a brief overview of my presentation. I will introduce my work in these 6 parts. The first one is introduction, which illustrates the background of my work, and the second part is the objectives and the methodology. As shown in the title, there is a survey of failures in a wind farm in China. And the third part is introduce start date of the wind turbine generators. And the third one, I will show the result of the survey of the failures in my work. And the fifth one, the further study with failure mode and effect analysis for the failures in the Chinese wind farm. And the final one, there is a conclusion in my work. Okay, let's give a brief introduction of the current development of the wind power in China. You will see in the 2013, the cumulative wind capacity in China has reached 91 gigawatts, and of which the 16 gigawatts were new added. And since 2009, the new added annual installation of the wind capacity have over the 10 gigawatts, and in the next year that value reaches the highest, nearly the 19 gigawatts. And by the way, in this year, and China had surpassed the United States and as a world leader of the cumulative installed wind capacity. And there is an overview of the why I would like to do this research. And with wind capacity growth, the capacity of an individual wind turbines also increased, and the size of the wind turbine generator is also scaling up. And there are a lot of surveys on the failures of the wind turbines. However, they focus on a variety of wind turbine generators, such as the different types of wind turbine and the different rated power of the wind turbines. But and at the same time, the start date of the failure is for a very long time. I mean, the only focus failures maybe during over 10 years, but the early failures in the new built wind farm was neglected. And in China, there are a lot of wind farm was new built, and they have a lot of the documents which recorded the operation and maintenance, and there are a lot of data related on the failures, but they didn't manage it and analyzed. So that's why I will focus on the early failures in the new wind farm in China. Okay. This study aims to quantify and identify the component failures in the started wind farm, and provide a foothold for the future research on the operation and the maintenance in the wind farm. And I would like to divide the wind farm into the several subsystems. For example, like the pitch system, which could control the blade to obtain the maximum wind power from the wind. And we would to further divided the subsystem to the component or the equipment to research, study the failures on the component level. Okay, a quantitative approach and a qualitative approach for statistical research in my work, and we use failure frequency ranking for the failures. We rank the failures based on the failure frequency and the downtime for each subsystem failure. And we use failure mode and effect analysis to identify the failure mode and the failure effect and the failure cause for the different components. And the failure mode is identified in the symptom through which the failure could be observed. And there is an overview of the wind farm. And we surveyed the wind farm. It's located in the southeast coastal region in China. And there are 134 the wind turbines with double-fired induction generators, each with a capacity of 1.5 megawatt. And all the wind turbine generators have been commissioned since the end of 2010. And so we focused on the 2011, and we found there are 691 failures events in 2011, and those failure events caused the outage of the wind turbine generators. And due to the failures, there are a loss of the 4.23 terawatt hour, which equates to 1.3% of the wind farm electricity generation during 2011. So I will focus on the that's the first year, first operational year for the new built wind farm in China. Okay, and before showing the result of the failures, I would like to introduce my studied wind turbine generators. Please see this picture. It is just to briefly introduce some parts in the wind turbine generator, and I divided the wind turbine generator to the subsystem and some main components just in my survey. And we identified the subsystem based on the location of the subsystem. You will see like the gearbox and the generator. Maybe in the different subsystems, they will have the same components, such as the bearings. So we will identify that they are different. For example, the gearbox bearings and the generator bearings. So and the subsystem and the components above in the subvision are independent, and it's not easy for all components to be shown in this brief figures. So they just show some of the important one. I hope this video could help you to understand the configuration of the started wind turbine. And you will see the pitch system in the hub, and which could control the blade rotate above the longitude of the blade, and with a system of the actuator to obtain the maximum of the wind power from the wind. And it through the main shaft transform the mechanical power to the gearbox, and gearbox increase the rotating speed and transform the power to the generator, and generator to produce the electricity and send to the grid. So this is the brief configuration in the nacelle of the wind turbine generators. And you will see there is a platform for the operator and the personnel to do some maintenance and some activities in the nacelle of the wind turbine. And you will see between the nacelle and the tower of the wind turbine there is a yaw system to help the nacelle to face the direction of the wind. And from this way, the personnel could access the hub, which is the location of the pitch system, to have some maintenance. And so this is just the brief introduction of the wind turbine generator. So let's move on to the result of my survey. And the figure 3 shows the proportion of the failure accounts for each subsystem, and the figure 4 shows the proportion of the downtimes per subsystem and component here. And we will see that the pitch system, which account for the highest proportion of the total failure frequency, and also account for the highest amount of the total downtime. I think it's because of they have the dominant failure frequency. So that's not reveal the pitch system have the longest failure time for each failure, but they have the highest amount of the downtime in the total downtime. Yeah, and we will see the generator, which was which was paid much attention to in literatures, and the gearbox, which is also regarded as an important part in the wind turbine generator, which have not too much failure frequency and the downtime in this survey. I think because it's just in the first operational year, so they didn't have a lot of failures to cause the outage of the wind turbine generator. Okay, let's move on to the further study on the pitch system, and you will see these figures shows some important components which have the higher failure frequencies. You will see the pitch controllers in the pitch system, which communicate with the main master control system in the wind turbine and send the commands to the actuator in the pitch system, and it counted for 36% of the total pitch system failures. And the slip rings is electrical connection between the hub and the nacelle, and the encoders could to measure the position of the blade and measure the speed of the electric motor, and the both account for the 17% of the total pitch system failure. And the battery sets, which include the battery charger, and some relevant circuits to supply the pitch system in the emergency conditions. So it also accounts 11% of the pitch system failures. Okay, and there is the further study on the component failure with FMEA, and this is a sample of the FMEA worksheet, and the first column is identify the component, and the second one have the function and failure mode effect to show what happened on this this failure, and the failure cause, failure detections tell us how we can find to observe this failure, and failure rate is just the other form of the failure frequency. and we will find that the pitch controller have the highest failure rate, and the loss of the communication is dominant failure mode. And this is for the generator system. We will see the vibration of the generator bearings is have the highest failure rate. And this is for the gearbox. We will see that in the first year, operational year, the leakage is critical failure in the gearbox operation and maintenance. And okay, let's conclude about the result. And we will find the pitch system having the highest failure frequency and the highest downtime. Is one of most critical part of the wind turbine generator, and it estimates that generator failures account for 5% of total failure events, and the vibration of the generator bearings have the highest failure rate, and the gearbox account for the 8% of total failure events. And the lubrication problem dominates the failures in the gearbox in the first year. Okay, that's all my presentation. Thank you.
Okay, thank you, Randy, for a very interesting talk. I'd like to invite some questions from the audience. Maybe start with the judges, Jonathan.
Yeah, thank you for your presentation. So you've done the survey on failure for particular Chinese wind farms.
Yeah.
So how will this work be used?
I would like to. This is just a preliminary study of my project. I would like to use this data to predict the failures in the future. Yeah. Yeah.
Yeah, Sasha.
Thanks for the presentation. I have a slight problem with this result in your conclusion, because you try to make general conclusions for double-fed induction generator type of the wind farm.
Yeah.
And you tested only one wind farm and one type of the wind turbine.
Yeah,
there.
yeah.
This is now
The
technology or specific wind turbine related, even including the manufacturer of this specific wind turbine. So I would be a bit more careful with this general conclusion for double-fed induction generator type of the wind turbine.
Yeah.
My question here goes as follows.
Yeah.
You have an exit.
Yeah. I know.
My question goes as follows. Have you compared these statistics with, as you said, a lot of surveys? There is not a lot of surveys, as far as I'm aware, but just wait, listen to me.
Okay.
And then we will get there with your answer. So, have you compared your results for 134 wind turbine wind farm with other available statistics? For example, in the UK there was a big project on reliability which is called Wind.
Yeah, I know.
And as far as I understand, there is not that big percentage of the pitch system failing, impacting the performance of the wind farm, because one important thing for that one is not just to compare the component failure in the wind turbine, because some of those, as you said, are failure in the battery system, which perhaps will not have strong impact on the output of the wind farm, because you can take care of it after you have the alarm without reducing production or having no impact on it. And particularly interesting was one type of the, or cause of the failure, which you said, bad connection.
That connection.
That physical connection of the
Yeah.
Okay,
Yeah, that's true.
I accepted that. So the question goes as following. Can you compare your statistics for component failures with other statistics available? And have you tried to relate component failure with actual performance of the wind farm or wind turbine output? So there may be no output, partial output, and turbine just happily working, although there is a failure in some of the non-critical systems.
I didn't compare with others, because I found just in literatures, and the only focus on the subsystem failure. I mean, they don't show some of the details on the failures. So that's a big question. That's a big problem on this region, I think. I think it's hard to compare with the others statistic, because they have the different definition. and the different how to say the classification for the failures. So I hope I could to find the different wind farm statistic and to compare them. I mean, maybe I this focus on only one wind farm and doubly fired induction generator, and I could find the other one. And
so we can agree that would be the next step.
yeah, maybe. Yeah.
Any other questions? I think we're actually running over time here. I'm quite keen to stick to
Sorry.
the schedule. So any other questions, maybe if we take them offline, if that's okay? There'll be some time to discuss that. Okay. So she's like to join thanking Ranby again.
This production is brought to you by the University of Edinburgh.